Okay, we're going to pick back up with chapter 16. I'm starting on 16.2 here on page 8. Chapter 16, you're not going to do any new chemical reactions, but what you are going to do is combine everything you've learned already so that you can do multi-step synthesis. And by that, I just mean you're going to start with a reactant, you're going to turn it into something, and then you're going to turn it into your final product. In order to be able to do that, you need to be very familiar with the reactions that you've learned, and they are all summarized for you here on this table. Okay, you don't need to learn this table off by heart, but you do need to get very, very familiar with it so that you are able to answer the questions. Okay, the more questions you do, the more familiar you'll become with this, and you'll have to use it less and less. So don't just sit down and learn it off by heart. Just use it over and over and over again until you become familiar with all of the reactions in it. I'm pretty sure we did this on Wednesday, okay? I've just drawn you out a few molecules. I want you to predict the reagents for the following, okay? Identify what functional group you have in your reactant. Identify what's changed in your product. So, for example, here, chlorine, okay? You've got a haloalkane, that's a functional group, but you still have a haloalkane in your product. That's not changing. What's changing is your alkene is disappearing and giving you an alkane. So when I'm looking for a reagent, I'm asking myself, how do I go from an alkene to an alkane? If I look at my flowcharts, I see if I want to go from an alkene to an alkane, I'm using hydrogen with a nickel catalyst. So I can write that in on my arrow, H2 nickel catalyst. In the next example, okay, I'm looking for a change. I've got here an aldehyde group, and here I've got a carboxylic acid group. The rest of the molecule is exactly the same. So I need to go from an aldehyde to a carboxylic acid. Okay, this isn't actually included on your table, but we should know that if you want to go from an aldehyde to a carboxylic acid, we need to oxidize. And if we oxidize, we're using acidified potassium dichromate. Make sure you remember your acid. You won't get the mark without it. In the next example, again, it's a larger molecule, okay? But the only difference between my starting product and my finished product is I've gone from an alcohol, my OH, to an alkene. How do I get from an alcohol to an alkene? I look at my flowchart and I see from an alcohol to an alkene, I need to use concentrated H2SO4. That will dehydrate it and it will give me an alkene. Then I look here, again, another complicated looking molecule, but everything is exactly the same until we get here and you've got an alcohol going to an aldehyde. Now I haven't drawn the hydrogen there. I can fill that in now. But if you see the absence of a bond, then you can just assume it's hydrogen. If it was a carbon, they would have to draw that line. So if there's no line there, then you know it's a hydrogen, you know it's an aldehyde. How do I get from an alcohol to an aldehyde? I oxidize it using acidified potassium dichromate. And then down here, your only difference, you're going from an alcohol to a haloalkane. That's going to be a substitution reaction. If you need to know how to do that, alcohol to a haloalkane, sodium halide, and H2SO4. The halide in question is going to have to be sodium chloride because I need to put a chloride, and then I'm using H2SO4. Okay, you do need to get really familiar with all of those reagents. I am pretty sure we went through this worked example already, so I'm going to flick on to the next worked example on page 10, which I don't think we did, but maybe we did. I'm going to go through it, okay? So we're starting with an alkene and we need to get to a ketone. Now, if you look back at your chart, you will see that there is no way of getting from an alkene directly to a ketone, which is way off down here at the bottom corner. So you need to go through an intermediate. And the easiest way to do this is to start with your product, your ketone, and ask yourself, how do I make a ketone? And there's only one way that you ever make a ketone. You always come at it from a secondary alcohol. It's the only way we've ever made a ketone, from an alcohol. So then you need to ask yourself, how are you going to get from an alkene, which is your starting material, to an alcohol? Because once you've made your alcohol, it's easy to get to your ketone. Okay, if I want to go from an alkene to an alcohol, you've had this on your recent test, okay? You need to add H2O, but it has to be in the form of steam. So I'm going to put a G, and I need an acid catalyst. I'm going to use H3PO4 phosphoric acid. Once I do that, I am going to add water to my double bond, across my double bond, okay? When I'm adding water across my double bond, I'm going to draw this without the double bond. and I'm adding water. So I'm adding OH to one carbon and I'm adding hydrogen to the other. Now, in order to get the right product, you will see that I need to have an oxygen on this carbon here, on the second carbon, which means when I'm adding my OH and my H, the OH has to go to this carbon and the hydrogen will go to this carbon. So I'm adding H2O across my double bond, but I have to put the OH here so that it lines up with my final product. Okay, now I've got an alcohol. I need to turn that into a ketone. I need to oxidize it. I'm going to use acidified potassium dichromate, and it will turn your secondary alcohol into a ketone. Okay, the next worked example, it says in this worked example, blah, 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 predict the reagents and conditions for each step. And this time the starting molecule has 2 functional groups, okay? And you're going through 3 different steps. Your first, again, they've given it to you just drawn out in structural formula. I would draw this out in full. I just think it makes it so much easier to see what you've got once you've drawn it out in full. So you have got a carbon double bonded to a carbon. Okay, that has a hydrogen on it. It's bonded to another carbon that has a bromine on it and a hydrogen. And then you've got a CH2. And in your next step, you have got a CH3, which I'm not going to draw, bonded to a CH2, bonded to a carbon that has a bromine and a hydrogen, and a CH3. What have I done? That's CH2. CH3. Oh. Sorry, that's clearly a typo in the book. That should be CH3, which makes that CH3. So going from molecule 1 to molecule 2, you will notice that the only change is you're going from an alkene to an alkane, okay? So if I want to go from an alkene to an alkane, I'm using hydrogen and I'm using a nickel catalyst. Then if I draw out my next molecule, I can see that I have gone from a bromine to an OH. Everything else is the same. How am I going to go from a haloalkane to an alcohol? I'm going to use sodium hydroxide. It's a substitution reaction. And then the final step, I'm going to go from my alcohol to my ketone. I'm just going to draw this out under here. CH3, CH2. I'm going to go from that to a ketone. How do I go from an alcohol to a ketone? I need to oxidize it. And there I have acidified potassium dichromate again. Okay, so just asking you for reagents. You just need to identify the functional groups that you've got, what's changing, and then what reagent you're going to use to make that change. I would like you now to do these questions by yourself and then tune into the next video for the worked solutions. Each reaction is 2 steps, so you need to give me the intermediate, how you're going to get from the starting reactant to the intermediate, and then from the intermediate to the final product. So work it out in 2 steps. You don't need to give me any mechanisms, you just need to give me reagents, and you need to give me the structure of the intermediate.